Good morning everyone. So today we are going to start a new chapter, chapter 7. This is all about differentiation. Now we had done differentiation last year also. Okay. Differentiation means rate of change of function. Okay. Let's say function is of x, then rate of change of y with respect to x. Clear? So we have few formula and we have seen this formula earlier also. Just to recall, we will just see this formula. Like here you can see the first one. It says that if you differentiate a constant, then you will always get 0. Okay. For example, if I write differentiation of 7 with respect to x, 7 is a constant. Okay, this 7 is a constant, so you will get 0. If I differentiate pi with respect to x, I will get 0. If I differentiate log a, where a is a constant, okay, then log a whole thing will be constant and I will get 0. Let's say I am differentiating e, where e is that 2.718. Okay, so again this will be 0 because here I am differentiating constant. Okay, so differentiation of constant is always 0. Okay, now see the next one. Here if you have any function of this type x to the power n, then differentiation will be n into x to the power n minus 1. Here n can be anything. Okay, it can be positive, negative, fraction. Okay, so for example, if I write differentiate x to the power 3 with respect to x, then here n is 3. Okay, so using this formula you will get 3 times x to the power n minus 1, that means 3 minus 1, so you will get this. Okay, if I write differentiate x square, so here this is not a constant. Okay, don't think that 7 is there so it's constant. It's a variable. Okay, you can see that x is involved with it. So 7 being constant, it will come out, you are left with this. Okay, now you can use this formula too. Okay, and by that you will get this 2 will come out and x to the power 2 minus 1, that means 1. So you get 14x. Okay, so second formula is also clear to you. Now see the third one. Differentiation of this e to the power x is always same, e to the power x only. Okay, now if you have this e to the power, let's say 2x, okay, of this type, m can be any number. Okay, like here m is 2. So in that case, firstly you have to think that this is a single. Okay, this is like same as x. Think for a while that that is e to the power x only. Okay, so you know e to the power something will give you that much only. Okay, now you differentiate this 2x. So when you differentiate 2x, that means you are doing this. Okay, so this 2 will come out, you get this, and then you are differentiating this. So here power is 1. Okay, so you have to use the second one. Clear? So you get 2 times e to the power 2x, and here 1, and here x to the power 1 minus this. Okay, so always remember that this will be equal to 1. Okay, if I am writing differentiation of this divided upon, so it will be 1. Okay, so you will get 2 times e to the power 2x. So this is what I have written over here. Okay, so third one is also clear to you. Now see the fourth one. So if you have something like this, then you'll get a to the power x log a e, where a is greater than 0, where a is greater than 0. Okay, you have to remember this. So for this type you will have something like this. Let's say I have 4 to the power x. Okay, so here this is your a, okay, which is greater than 0. So you have to use this formula. So you will get 4x and then log 4 to the base e. This is the differentiation. Okay. I have already sent this list to you all. Okay, formula list. So you all are expected to know it beforehand. Okay. So this was fourth. Okay, for fourth, if you have something of this type also you can do then. Let's say I have this 4 to the power, okay, 2x. So firstly you will get 4 to the power 2x. Think that this is x only for a while. Okay. Then you get 4 to the power 2x log 4e. Then differentiate this 2x. Okay. So if you differentiate 2x, you will simply get 2. So your answer will be 2 times 2 to the power, 4 to the power 2x log 4 base e. Okay, by this. So in this example, your m was equal to 2. Okay, and your a was equal to 4. Now see fifth one. So if you have this, if you have to differentiate this log x base e, then your answer will be 1 by x. Okay. And suppose you have something like this, log x, but base is not e, base is something else other than e. Then in that case differentiation will be 1 upon x, and here you will have log a to the base this. Okay. See the sixth one. Here suppose that u and v are functions of x. Okay. Then first one that I have written over here is this. Let's say you have a function y equal to 7x square. Okay. You can see that this is function of x. Okay. Where this is constant, where this is the constant. So if you are differentiating this, then you have to write like this, and this constant will come out. So you will get this, and thereafter you have to see which formula is applicable for this. So here second formula is applicable. So you can use and you will get your answer. This, that is 14x. Okay. So this was about the sixth one. Okay, where it's trying to say that this constant comes out. Okay, and this function of x remains here. Okay, and you have to differentiate it further. And the second one is, let's say your function is like this, y equal to 7x square plus 2 sin x. Okay, your function is like this. So here you can see that this function y is sum of two functions u and v, where u is what, 7x square, and v is 2 sin x. Okay. So in this case, when we are differentiating, let's say I have to differentiate this y, then I will write like this. Firstly I have to write like this, 7x square plus 2 times sin x, and then in the next step I can write it like this, 7x square plus differentiation of this 2 times sin x with respect to x, and then this by 6 1. Okay, this constant can come out. Okay, so this is clear to you. You don't have to write this explanation. Okay, I'm just trying to explain the formula. Okay, here you don't have to copy these things. You have to only write this formula in your copy. Okay, or you can write it separately in piece of paper, and you can attach with those formula that I had given you before. Okay, Next is formula 7. So in 7, suppose u and v are functions of x. Okay, we are going to discuss about the product rule. Let's say your function y, okay, fx is like this, sin x into cos x. So here you can see that there are two functions. Okay, this is u, this is v, and they are multiplied together. Okay, so for this, dy upon dx will be written like this using this formula. Once you have to keep one out, then you have to differentiate the other. Okay, and the next, when you are keeping the other out, then next one will be differentiated. So in this case, differentiation of this sin x into cos x will be written like this, sin x d cos x upon dx plus cos x sin x upon dx. Okay, so this is called product rule. Okay, so if you have two functions u and v and they are multiplied to each other and you are differentiating them, then you have to differentiate using this formula. Okay, this formula. Clear? Next one is quotient rule. So suppose you have two functions u and v. Suppose you have two functions u and v and they are of this type and your u is given this way. For example, if I write like this, y is equal to sin x upon x. Okay, or log x, anything. So here this will be your u and this will be your v. Okay, so dy upon dx will be given by this formula. Here denominator is v, so v will be written here, then du upon dx minus u dv upon dx whole divided by v square. Okay, so in this case your dy upon dx, u is sine and log v is your log x, so you will get log x differentiation of sin x with respect to x minus here sin x, then differentiation of log x and whole divided by log x whole square. Okay, so if you have any function of this type where u upon v type, then you have to use this quotient rule. Okay, next one is chain rule. Okay, this is very important. Suppose you have two functions u and v. Here I have made a mistake. Okay, so please correct this in your formula list also. It should be v. So oh no, correct. Sorry. Let u be let y be a function of u and u be function of x. Okay, then dy upon dx is given by dy upon du into du upon dx. For example, let's say y is equal to sin x cube. So here what I can do is I can put x cube as t. Then what will happen? Your y will look like this, sin t. Okay, and your t is going to be x cube. Okay, now you can differentiate y with respect to t. Okay, so when you differentiate this, you will get cos t, and you can differentiate this t with respect to x, then you will get 3x square. but I'm looking for dy upon dx. So dy upon dx will be given as dy upon dt into dt upon dx. You have already found dy upon dt, substitute the value, so you get cos t, and here into, so I can just put bracket and write, and dt upon dx is 3 times this. So you get 3x square cos, now in place of t, now substitute that, so you get x cube. So this is the differentiation. Okay, so this is the use of chain rule. Okay, but like you should try to do it directly only, unless you are asked to use the chain rule. Okay, because using chain rule, most of the time we waste our time. Okay, like here it was given y sine x cube, so you can do it directly also. You can straight write like this, and you know that differentiation of sine x is cos x. Yes, so just for a while you think that this is x only. Okay, this is x only, then differentiation of sine x, okay, is given by cos x, so you will get cos x cube, and then differentiate it again. Okay, so when you differentiate x cube, then you will get 3x square, so you will get the answer. Okay, so unless you are asked to use chain rule, you should avoid using that chain rule. Okay, because most of the time things will be more complicated for you. Okay, because you have to make a lot of assumption. Okay, and then instead of getting the answer in 2 or 3 lines, you have to do it around 5-6 lines. Okay. Okay, so till now whatever we have discussed, that is more than enough to do the exercise 7.2. Okay, so let us do few questions from 7.2. So okay, so this is exercise 7.2. Okay, before we do this, I want to just tell you one thing, that you should start in the first page. Okay, and you should give heading as chapter 7 differentiation, and if you want to write these given formula in the same page, then you may write. Okay, otherwise you can keep them separately, and you can always keep along with you whenever you are doing questions related to this chapter. Okay, and if you do this chapter properly, and if you understand, and if you can do it nicely, then believe me, the other chapters which are going to do in coming days are going to be very easy for you. Okay, you'll find it easy. So now let us see this question number 1. So here it says differentiate with respect to x. Okay, this is the function. Okay, so here you will see that this function has how many terms? It has got it has got 4 terms. Okay, but when we were looking at the formula, we didn't have any formula which involves this type of terms and all. Okay, all together collectively. Yes, so what we have to do is we can write them separately, okay, while differentiation, and then we have to use those formula. So see how we are going to do this. So exercise 7.2 question 1. Okay, so here they have not written that y equal to this or fx equal to this, so we'll write let y equal to x to the power 4 plus 4 to the power x plus log x minus 1. Yes, now we have to differentiate this. So this implies dy upon dx is equal to this x to the power 4 plus 4 to the power x plus log x minus 1. Now here you can see that this function is sum of how many functions? 1, 2, 3, 4. Yes. So we have seen here, if you have like two functions or more than two functions like this, then you can write them separately. Yes. So here in this question we have to use that only. So we can write like this: dy upon dx is equal to dx to the power 4 dx plus differentiate this 4 to the power x dx plus differentiate this log x minus, okay. Now dy upon dx will be equal to, now we know we have formula for this, yes, for something x to the power 4 type, yes, and that is your this formula 2, yes. So you can use that and your answer will be this 4x to the power 3. Then here you have 4 to the power x, we have formula over here for this type, yes. So we'll write 4 to the power x into log 4 to the base e. Then we have log x, we have formula over here, okay. So we will get 1 by x. Then here we have a constant, we have formula over here. If you differentiate a constant you get 0, okay. So your answer is this: dy upon dx is equal to 4x cube plus 4 to the power x log 4e plus 1 by x, okay. So here you observe that for this question how many steps we have done? 1, 2, 3, 4. In the fourth step we got the answer. But once you know all these formula properly, okay, and you know that how these things are behaving, okay, just looking at this you can give me the answer, okay. Just looking at this you can give the answer. That answer will be 4x cube plus 4 to the power x log 4 base e plus 1 by x, just by looking at it, because you know that here you can see this function is sum of 4 functions, yes. So you know that if you differentiate this you will get 4x cube, then plus sign, you know how to differentiate this, differentiate, right, then you know differentiation of this, you know this is a constant, differentiation has to come to 0, okay. So just by looking at you can answer it, yes. So that's why you have to know this formula, okay. Now see the second one, okay. Okay, so here is the second question. So we have to differentiate. So dy upon dx will be written as this: 2x to the power 3 by 2 minus 3 e to the power 1 by 3x, then here plus 2 to the power x plus this. Now in the next step what we are going to do is we will write like this: so if anyone would have asked you, given the do we have any formula for differentiation of this, so you don't have any formula for this. But now if I ask you, do you have formula for each term? Yes. So yes, we have. So here you can see that constant part will come outside, then you are left with this. Then here constant part comes out, you are left with this. Here this will remain like this, okay. And you know differentiation for this is given by this formula, a to the power x1. Yes, what do we get? A to the power x into log x, sorry, log a to the base c. Yes, so we have to use this formula. Okay, so use that formula, and here you will get 2 to the power x log 2, and here differentiation of constant is 0. Okay, so no need to write, just leave it like this. Okay, and here 2 is there, and you can see x to the power 3 by 2. So for this we have to use this formula, x to the power n. Yes, this will give you n times x to the power n minus 1. Okay, so use this formula. So here you get this into 3 by 2, then x to the power 3 by 2 minus 1. Okay, so how much you will get? You will get half, and here 3 is there, and e to the power 1 by 3 x. Okay, so we have to differentiate this. Okay, see over here, we know differentiation for this. Yes, exactly, e to the power x. So just for a while think that this is nothing but this whole thing is x only. Think that this whole thing is x for you. So what you should get? You should get e to the power 1 by 3x. Okay, but this was not actually whole thing x. Okay, it was 1 by 3x. Now what you do? You differentiate this now. Okay, now you differentiate this. So differentiate this, but this is constant. Yes, one second, let me write again. Okay, now 1 by 3 is constant, so that will come out. Yes, and then let me rub this also. So 1 by 3 will come out, and then you are left with this. Okay, differentiation of this will be how much? 1. Okay, so you simply get 1 by 3 e to the power 1 by 3x. Yes, so for this one we will get 1 by 3, then e to the power 1 by 3x. Done. Okay, now in the next step we have to just simplify and write down answer. Okay, so here 2 cancel, so you are left with 3x to the power half. 3 cancel, you are left with e to the power 1 by 3x plus 2 to the power x log 2 base c. Okay, this is the answer. Okay, so for this question also, if you had known the formula nicely, okay, then just in one step you could have written the answer. Okay, like here I know for the first term 2 is constant, so 2 has to be outside. Okay, then x to the power 3 by 2, I know I have to use that x to the power n1. Yes, so I will get this, and here 3 by 2 minus 1, so I will get half, then 3 over here, then here e to the power 1 by 3x. So firstly e to the power 1 by 3x, so I will treat this as a single, okay, as a x. Then I will get e to the power 1 by 3x only. Then I will differentiate 1 by 3x, so I will get 1 by 3. Then here 2 to the power x, I know I will get 2 to the power x log 2. Okay, this is constant, I know I will get 0. Okay, and in the next step I can simply cancel this and I will get the answer. Okay, so believe me, this differentiation is not tough. Okay, provided you know the formula. Clear? So this was question number 2. Now see question number 3. So dy upon dx you can write like this. Now instead of root x, can I write like this? X to the power this. Yes, you should remember that if you have, let's say, okay, first you remember this. This means a to the power half, okay, and sometimes if it's written like this here, okay, then it means that x to the power 1 by m. And sometimes if you see like this, here m, here n, then it has to be written x to the power n by m. Okay, please note this. So here we have root x, so that root x can be written x to the power half, and here no problem, leave it like this. Okay, now here we have to write them separately. Okay, so 3 log x, so 3 can be taken out, constant. Okay, so I'm trying to jump one step. Okay, and here I can write like this. Okay, now you know differentiation of each term. Log x will give you 1 by x, here x to the power half, that means you have to use x to the power n formula. So you get half over here, and half minus 1 you will get minus half, plus here we have formula for this a to the power x, yes, that it is a to the power x, we have formula, yes, but here we have something extra, okay, 2x. So what you do, just for a while you think that this is x only, whole thing is like x for you, think like that, okay, and then write down. So what you'll get 5 to the power 2x log 5. Okay, now what you do, you differentiate this 2x. When you differentiate 2x, okay, you will get simply 2. Okay, you can check that, yes, and then differentiation of constant is 0, so I don't have to write minus 0, leave it like that, yes. So here I get 3 by x, here 2 cancelled, minus here x to the power minus half. So you know that if you have something like this x to the power minus m, then this becomes x to the 1 upon x to the power m. So I can write like this. Okay, but again x to the power half will be equal to how much? Root x. Okay, so I can write like this, and here plus 2 into 5 to the power 2x into log this. Okay, so this is the answer for question number 3. Okay, this question also you could have just done in one line. Okay, because here I can see 3 log x, so I know this will give me 3 upon x. Here minus 2, this you have to do it in your mind. Okay, that x can root x can be written x to the power half, then half will come outside, then half has to be subtracted by 1, so you can get this also. Here also, just by looking at it, you can answer 5 to the power 2x, you have to differentiate. So you know that a to the power x formula, so think that it is like x for you. Okay, then you will get 5 to the power 2x, then log 5e. Okay, then differentiate 2x again, you get 2, done. This is a constant, you will get a 0. Okay, so you have to train yourself such a way, okay, that this type of question should be done in one line, or you can say you should be able to do it in mind. Okay, because this type of question will not come in the examination. Okay, these are like you can say basic things before we go to the advanced one. Okay, so this was question number 3. Okay, now see question number 4. Question number 4, y equal to this. This is given to you, you have to differentiate with respect to x. So dy upon dx. So you will write like this. Done. Now you can write them separately. So the first term, that will get 4 times d here, x to the power this, then plus 3 x to the power this. Now here you can see that 2 upon root x. So 2 is constant, it will come out and you are left with this. Yes, but 1 by root x. Firstly, root x can be written as what? X to the power half. Okay, see, this can be written as 1 by x to the power half, and then you don't want this in the denominator. So how you can write? You can write like this. Yes, so 1 by root x can be written as x to the power minus half. Okay, then plus 4 comes out, and then you get this 1 upon root x, 1 upon root x to the power 5. But again here you can see that root x to the power 5 can be written as this, x to the power 5 by 2. Now I don't want this in the denominator, so how I can write? I can write like this, x to the power minus 5 by 2. Yes, so instead of writing 1 upon root x, okay, to the power 5, straight we can write x to the power this. Yes, so this much is done. Now you know differentiation for each term. Yes, so for the first one I'll get this 5 by 4 x to the power. Now I have to subtract 1 from here. Okay, so 5 by 4 minus 1, I'll get 1 by 4. Okay, here 3, here 1 by 3 I'll get, and x to the power 1 by 3 minus 1. Okay, so I'll get minus 2 by 3. Here 2, that power will come down, so I get this, and then x to the power minus half minus 1, so I'll get minus 3 by 2. Okay, and here plus 4 minus 5 by 2, and x to the power minus 5 by 2 minus 1, so I'll get minus 7 by 2. Okay, now in the next step, 4 cancel, you are left with this, 3 cancel, you are left with this, then here minus, you get plus, 2 cancel, here plus, here minus, so you get minus, 2 1s are 2 2s are 4, so you get 2 5s are 10, so x to the power this. So you can leave the answer like this. Okay, so this was your question number 4. Okay, now see question number 2. Here it says differentiate each of the following function with respect to x. First one is this. So question 2.1. Let y equal to x cube into e to the power 3x. So here you can see that we don't have any direct formula for this. Yes, and you don't see plus or minus in between these two functions. It's multiplication, means product. We are taking product of two functions. This is u, this is your v. So here u is x cube and v is e to the power 3x. Okay, so do we have any formula for this type? Yes, we do have, and that is the product rule. Yes, which is equal to this u dv upon dx plus v du upon dx. This is the product rule. Yes, so in this case we have to use the product rule. Okay, see over here, this implies dy upon dx is equal to this. While solving this type of question, you don't have to write that let u be this or v be this, okay, because here you can clearly like differentiate between these two, okay, u and v. So here this is your, take this as u, take this as v. So what you'll do, you'll write x cube d e to the power this plus e to the power 3x x cube dx. Yes. Now you know differentiation of this and you know differentiation of this. Yes. So what we will get, e to the power 3x. See here we don't have, like we have formula like this, yes, but here you can see 3 is also included. So what you have to do is, you think that this is whole thing is like x only for you. Firstly think that this whole thing is like x for you, then you will get e to the power 3x, then differentiate that 3x. So what you get, you will get 3, and here e to the power 3x, then differentiate this x to the power 3, that means you have to use x to the power n formula, okay. So you get 3 and here x square, so you get 3 times x cube e to the power 3x plus 3x square, done. Now whatever you see common over here, take it out, like 3 is common, x square is common, e to the power 3x is common. So here you are left with x and here you are left with 1, okay. So this is the answer, clear? And the remaining question of this question 2, 3, 4, homework, okay, homework, you have to do this, okay. So let us keep it till here for today, okay.